Welcome to another episode of Tolly on Technology. Our topic today is benchmarking cloud-based applications, and we'll take a look at the challenges associated with cloud environments, as well as some solutions to these challenges. I'm Kevin Tolly, founder of the Tolly Group, and I'm joined today by Amritam Putatunda. Amritam, welcome. He is a specialist in cybersecurity-related technology and is responsible for technical product management of the applications and security business of Keysight. So migrating applications from in-house data centers to cloud-based platforms has been a trend for a while now. And the global pandemic seems to have accelerated that move for many companies. While running apps in the cloud has many benefits, it has created more challenges for the technical staff responsible for testing and benchmarking those applications to make sure that the performance meets the requirements of the organization. In our time today, I would like to explore that topic in more detail. Specifically, I would like to understand conceptually what you and Keysight believe are the biggest benchmarking challenges once apps are moved out of the data center and into the cloud. And then again, conceptually, I would like to discuss what type of testing strategy is appropriate to deal with those challenges. I know that you and your colleagues at Keysight have spent a lot of time grappling with these new challenges. So for the last minutes of our discussion, I would like to invite you to tell me and our viewers about the specific Keysight cloud testing solution and your near-term roadmap. Sound good, Amritam?
Sounds good.
Okay, good, let's begin. So there are a lot of challenges, but let's try to focus on the top 3 or so challenges. Amritam, what is at the top of your list when it comes to challenges of cloud benchmarking?
Thanks a lot, Kevin, for that introduction. And let's go through some of these unique challenges that we talked about. I want to share a quick one slide for our viewers to see. So when we were looking at this new post-pandemic networks, what we saw was there is a permanency to the changes that we thought were temporary when we were adapting to them during the start, right? The biggest one of it was that most of us, or some of us, would not be going back to the same offices, quote unquote offices, that we used to go there. And that creates a momentum towards these distributed networks, right? So what does the biggest challenge of a distributed workload be, right? The first thing is that your data, your servers, your collection of photos and everything else is now distributed towards multi-cloud, multiple physical locations and things like that. This was happening even before pandemic, okay? Pandemic didn't necessarily change that. What actually changed drastically was the users who were accessing the data from their centralized office locations or branches are now sitting at home. So instead of an office having 1,000 people, employees accessing their internet, social media traffic, and their office traffic, there is now 1,000 branches, one-person branches that has been created that are accessing traffic. Creates a very unique testing scenario or testing demand, so to speak, because when you move into this distributed networks, there are so many different elements that comes into being. You have your own internet service provider. You have the cloud, different cloud that have their own policies, internet gateways, NAT gateways, things like that. You have geographical boundaries and distances, like traffic, if you are accessing certain things from Ohio, can be very different from accessing from Iowa or from Santa Clara. So you have that physical physics law of physics, so to speak, working out. That's one part of it. That's the lack of control. The other thing is, if we consider why there is such a movement in distributed networks, why there is so many people getting distributed, it's because it provides very good flexibility. But everything comes at a price. The flexibility comes at a price of complexity. As we are moving to this cloud, they are providing us expansion, unlimited expansion and scale. They're providing us elasticity, where based on the demands, the servers would expand or contract. They're providing us amazing agility in developing our applications using containers and pods, where an application would be segmented and each pod will handle itself uniquely. And if there is a crash on certain sections, the Kubernetes systems or architectures will bring up those pods. Although this creates amazing flexibility, but it creates interesting complexity on how new applications are getting architected in this multi-cloud distributed environment. So these are the top challenges that we saw.
They become almost invisible to the people who are in charge of operating them.
Exactly. Yes. And so
Okay.
their names say cloud. Yes.
Yes, right. And yeah, as you said, it worked from anywhere, was on its way already. The pandemic turbocharged that. And as you read the news, for a lot of people, they like it just the way it is. It's going to stay that way. And that flexibility will be there probably permanently for a great deal of the workforce. But along with that, that increased complexity will also be there for a long, long time.
Right.
Okay. So then how do we go about, again, conceptually, reacting to or dealing with some of these new challenges?
Yes. So we, being one of the premier test companies of the world, understood very quickly that it cannot be business as usual. Our existing products and test tool that had serviced us for many, many years would not be able to handle the test requirements of those challenges. So we wanted to see how the testing itself needs to evolve to
Right.
address the new technologies and new deployments, right? So we prepared this 5 stages of network evaluating new networks. And if you allow me, I want to go through very
Sure.
briefly from all the 5 stages. The first
Please.
one, and probably the most important one, is the deployment. As I said, the biggest shift is not that the device under test software has shifted, right? Its software is pretty much the same. It's still blocking the same amount of attacks, still load balancing same amount of applications. Its deployment has changed. It is now getting deployed in cloud. It's deployed in SASE where you are not able to see it, right? So
Yeah.
we need to create a testing environment that can test this kind of distributed deployments while simulating the distributed clients, the post-pandemic office workers and the distributed applications, which are distributed over multiple cloud and multiple physical locations. So
right. So in the world before, prior to deploying, I would get the switch, the firewall, the balancer, put it on a rack in my test bed. I would hook up my Keysight test tool to it. I would run my layer 4 through 7, and I would basically have what I used to call a product on a pedestal. I'd have everything right there, and I'd know what's going in and know what's going out. When all that becomes cloud, all that disappears. So my methodology can't be to walk up to my test bed and plug something in because there's nothing to plug in. Right?
There is nothing to plug in, and the amount of variables. You cannot solve an equation. If there is 3 variables in the equation, you need 3 equations to solve for those 3 variables. So you need to somehow introduce it. Otherwise, it's a garbage in, garbage out.
Yeah, garbage in, garbage out. Yep. Okay. So clearly, deployment is a challenge.
Absolutely, and this is where, when you are evaluating your new networks, be it your new VPN systems, your SASE systems, your SD-WAN, your content delivery networks, you need to focus on deployment. It cannot be that, like you said, racks of servers sitting in a lab. You would get some data. That's just some data. That's not representing what actually will happen in the real life. Now, after that, the evaluation actually becomes significantly similar, because, as I said, the user's patterns have not changed. If somebody was seeing YouTube video, is still seeing the same video. If somebody was working through Jira or any other social, productivity applications, they are still using those applications. It's just that those have become distributed. So once you set the deployments, your second task, and the very important task, would be to baselining. Baselining is very important because you need to know if there are performance degradations, major performance degradations, and when exactly it happens. Baselining can start from very basic web performance, right? And then you can move up level, like encryption, mix of encrypted traffic and non-encrypted traffic, social media application mixes, conferencing apps. So you layer up till the application creates, the simulation is replicant of what exactly your network would have. So that's where the traffic and performance basics comes in.
Right. So what I'm getting here is we don't wait till we have a problem to decide to start benchmarking, because by the time you do that, I mean, obviously you can eventually solve the problem, but it's a lot harder when you don't have a baseline to work against. So you baseline, you have something that says this is what we normally expect, and the point that you make is really good. A lot of these things that we have on the internet are multifunction. They might have basic firewalls. They might have an additional web application firewall. They might be doing SSL decryption. All those are good functions, but all of those can impact performance too. So as I understand what you're saying, which makes perfect sense to me, is part of your baseline is that layered approach, which is, okay, we're just going to run through the most basic traffic, maybe some port filtering, or we're
Yeah.
just going to run through some basic HTTP without having to deal with TLS 1.3. But little by little, we're going to want to add those things on. So we don't have just a generic baseline, but we have a baseline with respect to the functions that are important to us. Am I understanding that correctly?
Absolutely. And if I have to say it in a single line, which I think many will relate to, we need to know what that new normal is, right?
Yeah.
What kind of
Okay.
in this new topologies and deployments.
Yes, exactly. Good points. Okay, good.
So the third point is, and this is where we are getting into more interesting aspects from the boilerplate stuff, is stability, reliability, and resiliency. And this is, nobody, the IT guy that has been, that doesn't get any calls is the most happiest guy, right? You get calls when
that's right.
starts breaking down. And stability, reliability becomes increasingly difficult to achieve in this kind of distributed networks, just because there are so many third parties that are not really in your control. What is in your control? In your control is your devices and your networks. So you can see or simulate some of those reliability issues and understand the processes that you might have to go through when it actually happens, or rather how redundant your systems are. If a server goes down, are you suddenly vulnerable to some level of security attacks, right? If an attack actually happens, what is your call flow in this new technology adaptations and things like that? So this might seem like very simple stuff, but in a distributed systems, this will happen more often than not, where certain systems will go down, certain traffic will not come up accordingly, and certain traffic will not perform. And pinpointing issues would become harder because of the sheer number of components and third parties involved.
So Amritam, here, are you talking about things like, essentially ethical hacking, use a test tool to conduct a denial of service attack and see whether or not it can be put off, or what happened? Is that what you're getting at here, or am I missing something?
That's definitely a small piece of it, but the larger piece of it, what we see in distributed systems is, for example, let's say you have an application deployed in a cloud. I don't want to mention any cloud name, but this cloud says that, you provision for 100,000 users, your application. But you know what, if let's say there is this one sudden demand where there are 150,000 users coming in, I will auto scale more server agents to ensure that during that small period of time, your 150,000 users are serviced, right? It's extremely—
So you get your elastic service, basically.
Yes, exactly.
Okay.
This is just one example I'm giving, where I'm just every time when I say talk about reliability and resiliency, people are naturally thinking about DDoSes and attacks and things like that.
Right.
In this environment, you also have to test application performance reliabilities, right? When elasticity.
Sure.
So I guess that was one of the examples I wanted to.
Okay, good. Yep, makes sense.
Now, the fourth one is probably my favorite one, is the security efficacy. Now, every time people talk about security, right? Unfortunately, in a lot of the talks, they talk about how secure a particular solution would be and how it would block all the attacks. And, justifiably, most security vendors think they are one of the vendors that are providing the most secured environment for customers. I'm not talking security here. I'm talking security efficacy. We have seen in our experience a large number of intrusion prevention systems, right, which customers have paid for, sometimes millions of dollars.
Right, not cheap.
I put in IDS mode, intrusion detection mode. And when we ask the customers, they say when they put the intrusion prevention systems, the amount of performance drop that they got would impact their business. And between better business and better security, even though it should not be, but business.
Choice, right.
And that's
what you're saying is because of the deep packet inspection, there's just too much overhead.
Exactly. And people just turn off the inline security a lot of times, right?
Ouch. Yeah.
Yes. Ouch, but it's a reality. I mean, I don't think anybody will disagree with us that a lot of key security features are moving out of band just because of the performance impact that happens. But again, when you're moving to this new deployments, that's where the second part comes in handy, because you have the baseline. When you're adding new security features, URL filtering, anti-spyware, malware detections and deep packet inspections, your baseline would be your guiding light. If you are going 90% below your baseline, that's a no-go, right? Definitely businesses won't allow it, because your users will not be able to do any of their businesses. But that's where you understand where exactly you lay the compromise between turning on URL filtering and the application and the impact it has on your performance. So that's where security efficacy is important, where you add applications and application traffic and then add security along with it, so that you can measure both and have a good efficacy score for your network and to be your own judge.
Yeah, exactly.
And last but not the least is the continuous assessment. So this is, again, new environments, new deployments, gives you flexibility because of the environment itself in a cloud. Things, spinning up virtual machines, spinning up agents in cloud is much more simpler than having something on-prem. So continuous assessment would be cheaper. With CI/CD pipelines, you can have this entire automation overlay using either Terraform scripts, Ansible, or different automation to spin up things in a continuous basis, so that you can understand the deltas as it happens, right? It's not like something you have to run the tests continuously, but over a cadence, you will understand, because of CI/CD, because of these continuous changes in the environment, you need to know the impacts before things get really bad. And that's where continuous assessment becomes a key piece in these 5 stages of evaluation of networks.
Yeah, I would imagine also it's key to service level agreement compliance, because you have to be able to show your users some data to say, yes, here's our SLA, and here's the data that shows that we're in compliance or exceeding what we're guaranteeing in SLA, right?
Yep, absolutely.
All part of it. Okay, good. All good stuff. I agree with everything you're saying. So obviously you've spent a lot of time doing this with Keysight, as we brought out earlier. I think our viewers would like to see some specific things of what the Keysight and you are offering up to folks in this area. You got some slides on that for us, Amritam?
Yes, definitely. So let's introduce the solution that we have been working for that we think would help in these 5 stages of evaluation. So this product is called CyPerf, and it's a ground-up developed product specifically for this kind of new age distributed network that we see. Now, I wanted to unpack some of the key features of CyPerf and explain you how this helps in these 5 stages. The first one is CyPerf moves away from the paradigm of you needing hardware or an enclosed virtual machine to run tests to an agent-based paradigm, which means you can install a software agent anywhere you like, in your cloud, in your on-prem, in your different locations, in your user's location. And that gives you that number one that I talked about, the 5 stages of evaluation, deployment, right? This is where you create your deployment that's representing your branch offices, your enterprise, and your users' distribution, and the same way your applications distribution as well. Now, that's one of them. The second is the auto-scaling aspect and the resiliency aspect. You remember the other 2 that we talked about, right? Where you also want to replicate the environment that you are in. That's a cloud environment where things can come up and go down any point of time. There can be container pods that spins up based on demands and container pods that spins off based on demands. You have to see whether you are securing those short-term pods, lambdas that are spinning up and down. And similarly, when the elastic scale happens, whether the network infrastructure is able to sustain that scale. You might have servers that can sustain 150,000 users. You might not have a load balancer that has scaled enough to sustain those users. And those are the use cases you need to find out. And this is where auto-scaling of agents being able to understand elasticity helps. The third point is the resiliency. And that's where you do the chaos testing, where you bring down servers, bring down forcefully traffic agents while the test is running. This gives you the features and functionalities to understand how good your redundancies are, how good your failovers are. Is your system actually resilient to some of these untoward events? That's definitely going to happen either today or tomorrow in this kind of distributed dynamic environment. Now, this is on the features of the agents itself. In the right-hand side, we focus a little bit on the traffic. Now, if you see, we send, like we mentioned, if we send agents and just have some port traffic, some ping traffic, we're not really replicating what's happening in a real life, what your users are doing. And that's where the realism comes comes in. So we added applications, application mixes. This is where we got a lot of help from our existing products, the on-prem products, because they already had those application signatures. And like I said, the applications or attacks have not changed drastically. It's the topology, the deployments, and everything else has changed. So we brought all these pre-built applications into our product so that you can do high performance application mixes, send attacks, and measure both the performance baselines and security efficacy, where you see what is the impact, both in terms of how good the solution would be in blocking new attacks when you add new features, but also how good it is in allowing the business traffic to continue. Will it make a huge drop of business traffic when I enable anti-spamware, or it's acceptable within that limit? So you'll be able to do that. And last but not the least, the UI itself is very cloud native, automatable, which is where your CI/CD pipeline comes in. So anytime you have some changes, incremental deltas, you have introduced new products, you've changed some policies in your security devices, you can run automation through the UI to see that your baselines are still intact, your security efficacies are still intact, and you have not introduced some new problems as the network and the infrastructure changes dynamically.
Okay, so is CyPerf a product or a service? Meaning, as I understand what you're saying as I go here, but do I get my licenses and I choose where I want to deploy the agents, or is there a CyPerf service that I tap into and you've got agents all over the world, or some combination of both?
Eventually, it's going to be a services as well, but right now it's a pure product. You get complete control. Nothing Keysight can see your UI or everything else. So you deploy your agents, you deploy your centralized mothership, the UI, and you control how you run traffic.
Okay. So I buy number of licenses or whatever, is that how it works? And then I deploy them where I want and register them and go from there?
If you give me a minute, maybe I can show you quickly how it works.
Oh, that'd be great. Yeah, go ahead, please.
Okay. Thanks, Kevin. In the interest of time, I will run a very quick test to show you how CyPerf looks. So this is my UI, and you can quickly see there is a create new test. This is the browse configs. This is where we have put all our intelligence, all this performance measurement, security benchmarks, so that our users don't have to rediscover the wheel to measure these deployments and 5 stages of evaluation that I talked about. So you can click on browse configs and you have all the different types of configurations that you need to do your benchmarking, do your security efficacy tests, and your continuous assessment. We also have a pre-created test for this configuration that probably would explain everything that I talked about. So this is my UI. So you can see what are the components here. I have my application mixes. I have my objectives. So this is, remember the performance baseline that we want to. I can quickly even add an attack here. Like I can say, okay, I need to send all my traffic encrypted attacks and some authentication bypasses, and I can just do that, and I add them, and then I add my agents. So this is my this is where the distributed topology or the deployment topology happens. Like I have my virtual machines in Santa Clara, I have my agents in AWS, I have my server infrastructure that is in AWS. So I can do some of these things and run tests. And when we run tests, the tests will pinpoint on the problems and the issues that you have, and give you insights, like what kind of performance insights I can see when I run this test, what kind of security insights I get, what's my throughput, what's my connections per second, what kind of latencies I'm seeing. If I'm seeing different latencies, can I drill down and see whether this latency is caused by a virtual machine or the latency is caused by my Santa Clara system? And you can individually see both applications and attacks to provide you the details that is needed for you to take decisions when you move into this distributed topology.
So you have the high level and the drill down.
Exactly. I couldn't have said better. We have the high level, which is my summary, and the drill down gets you to the bits and bytes of it as much as you need to find out issues, because ultimately that's the point of a test too, to pinpoint the issues so that you can take corrective actions and rerun the tests to see that the corrective actions has materialized into something fruitful.
Good. So I'm sure, given that it's a software solution, that you'll be expanding the application base over time. But what are the key applications available in the current release that you see people really wanting to use?
Very good question. And as I said, this is where we got a good head start, because we had all these applications for our on-prem kind of testing. So you can see we have a mix of social media, productivity, conferencing apps, Dropbox, Office 365, Facebooks of the world, YouTube. We are adding Zoom, Teams. The whole point is to create that internet infrastructure mix or enterprise mix, education mix, healthcare mix, so that any customer, no matter what kind of domains they are in, is able to create that kind of traffic mix and run it through, so that the performance analysis that they get is representative of what would happen in real life. And I'll repeat myself, if our applications are not realistic, if our attacks are not realistic, you cannot rely on the test data.
Kind of what's the point, right?
Yes, exactly.
Really.
Exactly.
Good. Okay, that was good. Good quick demo. So interesting stuff, essential for so many companies. Can you point our viewers as to where they can go and find out more about Keysight and specifically more about CyPerf?
Yes. So if you go to keysight.com and search for CyPerf CyPerf, you will get all information you need. I've also put some videos of some of these evaluations and stages and how to evaluate in our tutorials. If you go to YouTube, you'll get all the tutorials that you want. And CyPerf is also available in GitHub. So if you want to try it out quickly, you can download an automation template, deploy CyPerf, talk to us to get a quick license to have a trial of CyPerf and run it through. It's really easy.
That's great. All right, Amritam, thanks for that. And thanks for your insights today. Everyone, thanks for joining us, and check back soon for another episode of Tolly on Technology. Have a great day.